So we're going to wrap up Chapter 5 notes today, and it's kind of weird because we've been talking about lines, linear functions, lines the entire time. We just finished talking about parallel and perpendicular lines. We talked about slope-intercept form, point-slope form, standard form, and now we have this kind of weird standalone bit, which is graphing absolute value functions. But this is the flow that we go through. So we're going to learn about how to graph absolute value functions and how modifying them can shift them around a graph. Okay? So we already actually had the parallel absolute value function back in chapter 4. Okay? And so we know that what the graph of f of x equals absolute value of x is. Okay? This is the parent function. F of x equals absolute value of x. It's in the shape of a V with a vertex. The vertex is the point where the graph changes direction. So you're going to see the V, the bottom where it changes direction, or top in some cases, is at 0, 0, and lines have a slope of 1 and negative 1. So parent function, f of x equals absolute value of x. It looks like this. Okay? So V, lines have a slope of positive 1, right, and negative 1. So you can see positive 1, right, up 1, over 1, up 1, over 1, up 1, over 1. Negative 1, up 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1. This is the vertex. Okay? So all you had to do to graph that was start at 0, 0, which is where the vertex is, and then follow those lines, positive 1, up 1, over 1, up 1, over 1, both ways. Okay? Now, in the case of adding a negative sign, so what we're going to do is we're going to take that parent function and we're going to play around with it. We're going to see how different things can shift or change or flip that graph. So adding a negative sign outside the absolute value. See how this negative is outside the absolute value? What that's going to do is flip the graph upside down. So we're going to still have our vertex at 0, 0, but now the lines are going to go still up or down 1, over 1, but this way. Okay? So adding an absolute value negative on the outside, it's going to flip it. Now that makes sense, right? Because if we had f of x equals just the absolute value of x, something like positive 2 would give you positive 2. So you'd have 2, 2. But in the case of negative, the absolute value of x, you'd have negative 2. So 2 would give you negative 2 over here. Okay? Pretty straightforward. I think that's pretty simple. If you put a negative outside of the absolute value, you flip the graph. Well, if you add a constant, okay, outside of the absolute value, it's going to shift the graph up, okay? So here we have f of x equals absolute value of x plus 2. So that means it shifts up 2. Okay, so our vertex was at 0, 0. Now it's going to be at 0, 2. We're still going to have our slopes of 1 and negative 1. And we have the same exact graph, that same V, with slopes of 1 and negative 1, but it's shifted up 2. So you add constant to the absolute value. Outside of the absolute value sign, it's going to shift it up 2. Okay? Now, what if we subtract? Well, if we subtract a constant, if we have a negative constant, negative 2, outside the absolute value sign, that shifts it down. So here we have negative 2. We're going to shift down 2. And I'm not going to draw all the points, so I think you get the picture. But now we've shifted it down 2, right? Makes sense. Put 0 into here, we have 0, absolute value 0, 0, minus 2, negative 2. Put 1 in, we have 1, minus 2, negative 1. Here, we had 0, put 0 in, 0 plus 2, 1, 1 plus 2 is 3. All right, we're going to keep moving on. I'm going through this relatively quickly because I think it's pretty self-explanatory, at least I hope. Okay? Now, this is where it gets a little tricky. If you add a constant inside of the absolute value sign, it shifts the graph to the left, okay? So, if we have the absolute value of x plus 2, but this is inside, right, instead of outside, then it's going to shift to the left, right? Shift 2 to the left. Okay, so now we're going to go to left 2, so we have negative 2, 0, and we're going to have our same line like so. Now, why does that work? Well, let's just plug negative 2 in. Let's just plug 0 in. Plug 0 in. 0 plus 2 is going to give you 2. Plug negative 2 in. Negative 2 plus 2 is going to give you 0. Okay? So having that inside the absolute value shifts it to the left. Outside shifts it up and down. As you're probably going to guess, inside shifts it left or right. So if we have a negative constant added in, so a subtraction, then it's going to shift it to the right. So here we have inside the absolute value. Okay, so it's going to shift 2 units to the right. Okay, so we're going 2 over. And we get a v that looks like that. All right. Finally, 2 last ones to look at, and that is if we have a constant that multiplier on the outside of the absolute value. Okay? So multiplying the absolute value by a number greater than 1 increases the slope of the graph. Okay? So we have f of x equals 2 times the absolute value of x. Well, here, our slope has now become 2, right? Or negative 2. And you're going to see what I mean by that. So here we're going to have the same 0, 0, right? But now, instead of going up 1 over 1, we're going to go up 2 over 1, up 2 over 1. So our v gets thinner. And here we're going to have the negative 2 slope. So up 2 over 1, up 2 over 1. And we have a thinner or narrower v. Okay? If we divide, we get the opposite effect. So dividing the absolute value by a number greater than 1, which is the same as multiplying by a fraction less than 1, decreases the slope of the graph. So now our slope is going to be 1/2 and negative 1/2. Okay? So we still have 0, 0, but now we're going to go up 1 over 2. Up 1 over 2. This is going to make our graph wider. Our v gets thicker, our angle becomes more obtuse. Okay? So I know I went through that pretty quickly, but I think it's pretty self-explanatory. Let's just talk through them all once more time really quickly. The parent function of the absolute value looks like a v with a slope of 1 and negative 1. The 2 lines cross are the point where they meet is at the vertex, okay? And they go out in those directions. If we add a negative outside of the absolute value, we get a flipping of the graph, so it's now going downwards, the v. If we add or subtract on the outside, it's going to shift it up if it's positive, so here goes up 2. Down if it's negative. If we add inside, it's going to shift it to the left. I'm sorry. If we have inside, it's going to shift it to the left. I was looking at the bottom one. If we subtract inside, it's going to shift it to the right. And then finally, if we multiply by a number greater than 1, it's going to make it narrower. It's going to increase the slope. Multiply by a number less than 1, that's like multiplying by a fraction or dividing. It's going to make it fatter. That's all we need to know about absolute value functions and their graphs.